Okay, so good morning, everyone. Today we're presenting our project on modernizing black hole routing for enhanced network security, or PHR. My name is Razan, and I'm here with Rama, Jude, All, Polina, and Chewing, and our team leads are Eric and Vanessa. So what is PHR? Black hole routing is a method where suspicious or harmful traffic gets silently dropped by the router, like it disappears into a black hole. It's what Duke's security team uses to block bad IPs trying to attack or scan the network. So the PHR system flow, first of all, the router sees all the incoming traffic, then Splunk analyzes it and detect any suspicious activity using smart queries. If an IP looks malicious, it's sent to a BERI, where it's either blocked or allowed. And then our PHR takes over and instantly does the actual blocking for the bad IP. And then the router updates to drop any future traffic from there. So the whole flow is automated and fast. As for our tech stack, in the front end, we use HTML and CSS and Python Flask. For the back end, we also use Python Flask with Docker for easy deployment. And then for our database, we use PostgreSQL integrated with SQL Alchemy. So using these simple tools, that's what made our PHR system efficient and scalable. And now I will hand it over to Jude.
Hello everyone, I'm Jude, and I will start with one of the main features that enhance the system performance, which is the database. Initially, we actually have four main tables to handle the main operation, which is like the users, which is contain the ID, net ID, role, if it's admin, viewer or editor, when been added, and the token value. The token value actually it's been connected to as a foreign key to a user table, which is contained a user tokens table, which is contained the ID, token value, net ID, when been created, and if this token be revoked or not. Also, we have the block list, which is contained the ID, the IP address created by, comment, added at, and when it will be expires, and the duration, and how many times this IP been blocked. Also, we have the save list table, which contains the ID, the IP address, created by, added at, comment, duration, and expires at. But since the performance is one of our key objectives, we brainstorm a way to optimize the database. So we came up with two main solutions. The first solution is if a block request is received for IP address that already exists in the table, instead of keeping the duplicate in the main block list table, we move the existing record to a table that's called block history, and adding the new record for the new block and increase the block count by one. This will keep the main table clean, reduce the duplicate entries, and improve the query performance. The second solution is if or when a block IP actually pass the expiration date, in our case or the default case it's 6 months, we move the record to a table called historical, which is act like an archive. This way, the main tables actually remain lightweight and the long-term data is still proceeded for editing and analysis. Actually, as you see, the additional tables down the block history and historical were created to support this logic. And now, we will move to the next feature.
Thank you, Jude. So next up, we'll be talking about the authentication. So in our system, there's three different roles. There's the editor, viewer, and admin, and we'll be showing that now. So an admin currently is going to be adding a new user. In this case, it is AKK55. And as you can see, there's three different options the admin can choose, either making them admin, editor, or viewer. In this case, we're going to be looking at the viewer and seeing how it differs. So the admin is temporarily given the password, as you can see here. Then they give it to the user, right? So the user then inputs that temporary password in. And then the system automatically forces them to have to change this password. And this password is safely hashed in our backend. So after logging in on the viewer side, right, you see four main tabs, but you notice the users page isn't there. Alongside that, we made sure that the viewer cannot add anything besides for API tokens. Now we're going to be taking a look at the admin page. So on the admin side, you can see the users page, and then as long as with all the API tokens as well. And the API tokens are used for Splunk apiaries so that they can automate and use our system with tokens and other tools as well. And there's also 3 different options for that. Only admins are able to see the API tokens, and then the other roles are able to see their respective tokens and be able to use it, and it's temporarily shown in the JWT format. And now I'll be passing it on to Chewing. So this part is also I don't know if Chewing may be having technical issues, but this part now we're going to be covering the better dashboard. So the dashboard in the old BHR lacks certain aspects. It only shows stats for 4 different aspects, and in our case, we're showing we have our much more updated dashboard, and it includes it's faster, quicker, even with the amount of data that we have. And we made sure that there's data filtering in it. So you can see either today, within the last week, in the last month, however you want. And we have the export PDF function, which is used to show easily show this information and send it out to whoever needs to see it and be able to process it conveniently. And then we'll be now showing the next feature.
So the next feature that we have in our system is the CRUD functionality, or the create, read, and update functionality, along with the related usability features. So to explain how the CRUD functions work on our website, let's start with an example. Let's say that Duke's security team receives an alert from a detection tool that they use in the system, and that tool flagged a suspicious IP address that was attempting to do a brute force attack. To handle that, our BHR enables the IT security team to add the IP directly to the block list. Let's now walk through how that's done using the CRUD operations on our BHR system. So as you can see here, I'll start by adding the IP to the block list. We can choose between setting a specific date, entering the duration in hours, or blocking it permanently. And you can add a comment for context. And once that's added, the table updates and the counter as well increments. Now, let's say that after a while, we wanted to extend the block because the attack continues from the same IP. We just click on update, add more hours, or change the comment, and then save. And the table gets updated. And if a block is no longer needed, we can directly delete it. You can select even more than one at a time. And before deleting, a confirmation pop-up would appear to prevent any mistakes. Now let's continue with the safe list, which includes the same core features. All the CRUD functionalities that are available on the block list page are also present here. But now let's explore the usability features that are also available on both pages. So as you can see here, we have the add IP, we have the delete, we have the update, and all the core features that are just explained in the block list. As for the usability features, first we have the pagination. You can customize how many IPs you want to appear on a page, and you can flip through those pages as needed. We also added a search field. You can search by an IP or a part of an IP like a subnet, and matching IPs would appear. And lastly, another feature that we added is the sort. Just by clicking on column headers, you can sort entries by either IP, duration, or any of the columns. And that's how the CRUD functionalities work to manage the block list and safe list on our system. Now let's continue with the next feature we built.
So our next feature is IPv4 and v6 capabilities and also subnet recognition. Here's an example of a user adding an invalid IP address to the block list. You'll see that when they input it, they get an error, and this works for if you're adding an entire invalid subnet as well. Next, we'll attempt to add an invalid an IP address that's already on the block list to the safe list. One of the key purposes of BHR is to stop the IPs on the safe list from being accidentally blocked, and vice versa. You can see it working here. However, this can be pretty easily overwritten, as you can see with this yellow button at the bottom, for testing purposes. Something that's not shown here is that if you try to add a really large IP, say a /10 subnet, it's not going to work because we want to prevent users from accidentally adding IPs or adding subnets of, say, 4 million IPs to the block list or safe list. Passing it on now.
Thank you, Polina. So next up, we're going to be going over our customizable UI UX. The purpose of it is so that other universities can adopt our features and be able to use the system. So in this case, it's being shown for NC State, and it's really easy. All you need to do is change about 10 lines in our backend, and boom, it's a completely different front-end website. We're using different components for each of the aspects as well, like the messages, pagination, a dark mode. There's also the adjustable side menu as well, as you can see here. And these features are meant to want to have the user be more active, more involved on the site, as well as using the scripting, of course, but making it so that it's easier for the other universities to make their branding and adopt their branding into our BHR. And now we'll be passing it on to the stats.
Now that you've seen how our web app works, you might be wondering, how does it perform at scale? During recent testing, we've added up to like 1 million IP addresses all time and added 30,000 IPs to the safe list. And when those safe listed IPs are being cross-checked with any IP that you want to add to the block list, it takes less than 20 seconds. And when you're adding up to 1,000 IPs to the block list at one time, they can be blocked in less than 1 second.
For the future plan, we actually we have three main goals. First goal is we are planning to integrate triple single sign-on to enhance the authentication and ensure secure centralized access control. Also, we will continue testing and fine-tuning the system, especially focusing on optimizing the speed of the block list and safe list operation. Actually, and then once we are fully tested, our goal is to deploy the system in real environment and begin actual usage within the network. Now I will hand it to you, Polina.
So I just want to give a huge shout out and thank you to everyone who's been helping us throughout the project. Thanks to our team leads for being patient with us during the stand-ups, Jen and Sherry for coordinating the entire Code Plus, Alex, our sponsor, for giving us good advice during the feedback sessions, and Kieran and Rudy for helping us debug all of our Git issues throughout the summer. Thanks again.